All right, good morning everyone. We'll kick off today's session. So this is the infrastructure, software and capability stream. And to start off, I'd like to acknowledge the traditional custodians on the land on which we're meeting today, the Yagara and Turrbal people. Pay my respects to their elders past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders here today and online. So our first talk this morning is your eResearch ready for HPC DL AI as a service? So I'd ask Werner to, there he is, over here. Just quickly, if you do have a question, if you can pop to a mic or just raise your hand and I'll pass the mic around. Thanks.
All right. Thank you for the introduction. Great to see everyone here, and actually very good attendance here in this session. So thank you everyone for coming. My name's Werner Scholz. I'm CTO and Head of R&D at XENON Systems, and would like to kind of really start out with a few questions then around eResearch and providing infrastructure and platforms really as a service, and if you're ready for that. Just as a very brief background, XENON Systems been around now already for more than 25 years. We've been involved in a lot of projects around HPC, deep learning and AI, and we've also been working with defense and a lot of enterprise customers. We've been closely involved in the delivery of the Rygen system at NCI, for example, at the Gaudi system. In between, we delivered the Agility platform. We delivered the Bragg system for CSIRO and a variety of other customers. So we have a little bit of experience at HPC, really including compute, but also networking and storage. And in the last few years, really, we have seen that transition where compute is really kind of becoming an add-on around data, and it's all about data management and data storage. And on top of that, it's really all about the users and their workflows and their applications. So let me start out with a few kind of leading questions. User expectations around eResearch. What we see pretty much every day when we talk to our partners, when we talk to our customers, when we talk to the users who we directly support on a variety of platforms which we run for our customers. User expectations are usually around, I need more storage. Anyone heard that before? Yeah. I want to store everything forever. I can't delete any data, anything, ever. Anyone heard that before? Yeah. I can't lose any data, so you better make sure that you, whoever is running the platform, don't lose it. And I want to access all my data instantly, right now. So not going through the whole list, but it's really showing that expectations of the users are getting to the point where we need to figure out how can we actually fulfill that. How can we fulfill that now? How can we fulfill that tomorrow? And really enable the research to become more productive and become faster. And it's not only around the data, then it's also around the applications, where people come up with all kinds of interesting applications. Either they wrote themselves. Hey, can you please compile this for me on this new piece of kit where it's supposed to be run 10 times faster? Or I found some code somewhere here in a dark alley of the internet. Can you please make that run for me? I need that right now for my research. Of course, that all gets even more interesting when you have not only a single platform anymore, a single CPU, for example, but when we deal with multiple types of CPUs, multiple GPUs, and everyone wants it compiled and optimized for everything. So, but it doesn't stop there, because users also say, I want all this now, and no, I don't want to sit behind my laptop and or my old-fashioned PC and have to write a long-winded justification why I need all this. I just want it now. I don't want to get multiple quotes. Well, maybe I find somebody else in the IT team to do that, but I don't really have to apply for a grant because I have a credit card here. And for the first whatever month, I'm even willing to kind of spend my own money on that just to get started, if you can help me get started now. Because the usual process is then you also have to wait for the grant to get approved. You need to go through a procurement process. You have to wait for 6 months, nowadays 6 months if you're lucky, If you're not so lucky, you have to wait for a year for that switch to arrive to actually be able to lash all your equipment together. So anyone heard all this before? Yes? But it gets better because there's the cloud. The cloud is magic. And depending what your state of mind is, maybe after a few interesting evenings, maybe you see it colorful like this. And the magic cloud's going to solve everything for you. Last but not least, because your users, they have a credit card. That's probably the biggest weapon nowadays. And this credit card's going to fix everything. If you've heard all this before, maybe you're also ready for eResearch as a service. What does it really mean? It really means we have to worry about, at the center of it, data storage, capacity, growth, performance, throughput, and latency. We really have to worry about data management. And data management tools like Discover, for example, becoming really, really core to just performing eResearch. So of course, compute performance, but we can provide compute performance kind of around the storage, let's say relatively easily. But then you have to lash all this stuff together with networking, either on-prem or also in the cloud. You have to worry about how do you provide the network performance you really require to get your data to your compute and save the data and make that really productive. And of course, you have to worry about archiving, where do you put your data, how do you transfer it, how long does it take? These are all the fun challenges we have. The photos here, the photo of the networking here is, for example, the spine switches in the agility system at NCI, which we delivered and put together. We have our own cluster stack to facilitate a lot of that. And this little monster down here is actually a virtualized HPC cluster we delivered to the Walter Eliza Hall Institute a while ago. So with that, we tried to come up with a solution that allows us to span all of that and make that really a flexible platform for our customers, what we call XENON Cloud. But for us, XENON Cloud is really more a concept that spans not only installations and platforms in hypercloud, but also on-prem or off-prem in a third-party data center where we can run this for our users and for our customers. What really makes it different is that we are optimizing this for the workloads and workflows. We worry about what actually runs on there and support the users directly. We have, of course, the compute, storage, and networking requirements in mind, working towards a budget, and we can support this on a variety of platforms. Again, where does it then run? On-prem, off-prem? We can take care of that, completely partner serviced, or we can run it in the cloud with one of the hyperscale cloud providers. Who manages it? Which is really a question of, do you still have enough resources in your IT team to actually support a platform like this? And we see more and more environments where that's unfortunately not the case, which in the end is really holding back the users and the researchers, because if they don't have enough access to resources to help them install that new application, optimize that new code, that's really delaying their progress. And we're trying to help and support that by managing the whole environment. Of course, we also work with customers who then want to take it over and manage it themselves. So that's a perfectly fine option as well. Access in the end for the users nowadays means I just want to fire up a web browser, I want to get access to a portal, and I want to get access to the HPC environment. I don't want to have any kind of convoluted tools I need to install or something. That's pretty much the expectation. And I want in my web browser full 3D accelerated graphics. And we can deliver that pretty much on all these platforms we've discussed. Of course, somebody has to pay for it. If it's not you, maybe it's the IT department or somebody else who at the end has to either get out the credit card to pay for that on a monthly basis, which as kind of operational expense becomes more interesting for a lot of organizations. Or we can also offer solutions where you can have a fixed commitment and pay for that upfront as CapEx. When is it ready? This solution for us and customers is ready now. We are already running multiple installations like this for our customers in the region and also overseas. Just looking at typical examples, right? This is a kind of very standard HPC architecture. You have a user that gets access to a login node. You have some compute nodes behind it. You have some shared storage, whatever that might be. to store all that, right? That's kind of at the very basic, very simple HPC environment. If we run this now in a hyperscale environment on Azure, it actually looks all the same, right? You have a user, gets access to some kind of front end, depending on how that's implemented. You can have a license server there if you have some commercial applications. You have a job scheduler running somewhere, typically Slurm or PBS nowadays. You have a set of VMs, which are in the hypercloud usually turned off until there is actually a job coming along. So then you can elastically scale that system and bring the VMs only up when you need them. We have to worry about storage, which in the cloud is, of course, a little bit different from doing that on-prem. You might have a Lustre system on-prem or Spectrum Scale or something like that, or CFC upstairs, right? Partners from Weka or Vast have solutions in that space. In the cloud, you really have to worry about how do I deliver the performance to the application without breaking the bank. And again, that's now an interesting optimization exercise, which you can then do, but you can do live, right? You can start out with on Azure with Azure NetApp files, and then transition to something like a BGFS file system that might be running on demand across the compute nodes. But in the end, the basic architecture is really the same. If you look on AWS, where we've also implemented that, again, you have gateways which give you access into the environment, you have some shared storage, you have your compute instances, which are then auto-scaling across the EC2s for the compute on demand, and you have access through remote desktops. So once again, no matter which platform you're basing on, the basic architecture for classic HPC is the same. But then you might want to go a step further and say, I want to have a solution that's really cloud native. Why do I still need to run a head node? Why do I need a scheduler? The cloud is infinite until the provider runs out of resources in the data center. You can't spin them up, but these are details. You can have an HPC cloud headless where the users, and again, we've implemented that for customers who run all their stuff locally, who still store their input files and their models locally, and then who just say, I have all my data here ready, I just want to get that executed. I don't care where it runs. I don't know what it looks like. I don't know how it happens. I just want to get my results back, and I want to get them back as soon as possible. So then you can have an architecture where you automatically triggered, the data get uploaded into persistent storage in the cloud, you have your application container, you prepare your job, that then launches the number of virtual machines you require or the instances. Once those are complete, those runs, again, they're stored somewhere in persistent storage, then you can already ship that off into some cold archive if you want to, or you just transfer it back, possibly even to an on-prem storage solution which closes that loop. And the nice thing about that is that the customer doesn't even know, or have to know, or the user, I should say, doesn't even have to know what's here in this box. It's kind of a black box that just executes it. And pretty much all the cloud platforms support that model. The other nice thing is that you still have all your data on-prem. You just have to worry about egress charges for the data coming back. But again, that can be designed appropriately. And when you don't have anything running, you don't have any of this stuff here up, which means your cost goes to zero when you don't run anything. Because we don't have a head node, we don't have a login node, we don't have a job scheduler, because in the simplest case, the assumption is that whenever I want to launch my job, there will be resources to launch them. Again, asterisk on that, that might not always be true, depending on how big your model is, how many runs you want to do. If you need 10 or 20,000 cores tomorrow, maybe we have to talk a little bit more if they're actually going to be available. But for lots of smaller projects, that's also an interesting solution, which is really cost optimized, going to zero when there is no need for resources, and otherwise it just executes the job and you don't have to worry about any persistent resources. The other nice thing is that we have automated this whole process of setting up these environments now, talking about it, setting that up in hypercloud, from zero to an auto-scaling HPC cluster in about 20 minutes. The 20 minutes are actually not constrained by us, how quickly we can type on the keyboard. That's really just constrained by the hyperscale provider how quickly they can provision the resources to bring up the system. The other nice thing, of course, in cloud is that it's auto-scaling. You really spin up only as many compute nodes as you require, and then you can turn them off again when they disappear. The interesting aspect about that is that in many cases, you actually don't want to turn all of them off, because it takes a little bit of time until the next VMs come online for compute resources. So depending on what the workload profile is, you actually want to keep a few around so that you can immediately start a job when there is a new model to run. Hardware options, the nice thing about this is that you have a lot more flexibility if you actually run it in a cloud environment and you don't invest into your own resources, because as soon as new instances come online with new GPU types, new FPGAs, even new CPUs, right? You can have ARM cores now available in the hyperclouds. They, of course, can be used as soon as they become available, which gives you a lot of flexibility. We talked about the workflows and the support already that our team can provide there. Data storage is really a big topic that needs to be discussed every time. Where do you store the data? How long do you need to preserve it there? Do you want to bring it back on-prem? Do you want to ship it off into some deeper archive and save costs that way? But for many customers, what really in the end matters is they want to see these services provided as a service, fully managed by someone who has enough resources available because of the resource constraints we see in a lot of organizations and teams nowadays. And of course, then the cost model can be also this pay-as-you-go with the big weapon, remember, the credit card. With that, I'll wrap it up here. Thank you, everyone, for your attention. Any questions, comments, concerns, any wonderful stories anyone wants to share? Yes.
Hi, I'm Maciej from CSIRO. Oh boy, actually, I could talk to you for a long time, starting with some stuff which is pretty adversarial because I come from HPC on-prem background. But I don't want to rain on your parade, so I just stick with one technical question.
Sure.
How well your cloud provisioning is integrated and supported by Terraform and Terraform Enterprise?
So that's kind of a question of who wants to bring up the environment themselves. In our case, we have our own automated stack developed so that we can get you that complete HPC environment ready in those 20 minutes. Our solution right now is not based on Terraform. I realize a lot of other teams who build their custom solutions are using Terraform for that, which is just another tool to bring up such an environment. If you are interested in that, we can have a conversation about this, how we can support your team if you want to have such an environment based on Terraform.
I don't think we are ready for that, but so your own stack, is it clickety-click GUI, or is it like as infrastructure as code? It just not using your own tool instead of Terraform?
This is essentially infrastructure as code because we really just have an automated script that in the background on the hyperscale platforms in the background is using Terraform. But we don't even have to go to that level because that's already kind of provided. We're sitting on top of that, and we just have the script to execute that and get the platform up in about 20 minutes.
Okay, thank you.
So it is fully scripted, it is fully automated, it is fully repeatable.
John Zaitzer from the University of New South Wales.
Sure.
One of the things that we find with our on-prem Katana cluster is the amount of software that we install. In fact, we have well over 2,000 packages, and I think an average of 5 requests come in every day for a new piece of software that some researcher wants somewhere and has no idea. How do you manage that? Or do you just say, no, these are the software apps that we support and that's it? Or 2,000?
The user and the researcher is king, right? All hail the king, and we'll do anything to help. Realistically, again, we don't want to be the barrier that blocks the progress in research. And so I don't think we really have an option to say, no, you cannot try this cool new thing, because that would be like saying, no, you can't do this research. So we are in the same situation. We're supporting universities and customers around the country where we also have platforms which have 2,500 to 3,000 applications and libraries managed in easy build that we have to support for our users. Same situation. I don't think that's going to go away as long as we want to truly support those researchers and customers. What makes it more fun is when that's all optimized for one CPU vendor, and then now you start buying from another and you have to recompile and re-optimize. How to handle that, maybe we can talk more about that, but that kind of doubles the fun.
We're investigating SPAC for this.
Yes, that's one of the options. Still, hand tuning that's then sometimes required still needs somebody to invest time. But that's again the point that we can help with that as well. We have experience for that. With that, we have been doing that for many years, and we can augment the teams who are just running out of time and resources with that. All right, with that, thank you very much for your attention. You can find me afterwards. I'll be also at the stand. Feel free to stop by and we'll have some more conversations. Thank you.